Hello, I'm Vincent NOVELLINO.
Hey, I'm VOORHIS.
Hey, I'm Anjaney MAHAJAN.
Hey, I'm Samuel Fox, and we're team 2468.
Okay. The engineering problem for this project was to design and build a light-sensitive probe that would measure Cherenkov radiation, aka blue light radiation, produced by NC State's pulse star reactor. The function of the probe was to determine the amount of power being produced by the reactor.
So, part of the research for the project was we had to look up what Cherenkov radiation is. And Cherenkov radiation is actually a pretty simple concept, where the speed of light of the electrons exceeds the speed of light in the medium. The speed of light in the medium can be determined by dividing the speed of light in a vacuum by the refractive index of the medium. And because of this process leads to the release of photons in the blue spectrum.
We started with a bunch of different designs, and we ultimately got to one that we used for a nuclear reactor probe by creating a decision matrix. This decision matrix was created with different criteria and constraints needed for a nuclear reactor probe. Some of these constraints were ease of use, waterproofability, portability, and cost. And we gave each of these criteria and constraints a number from 1 to 3 based on importance.
Okay, in order to build a reactor probe, we had to procure a number of different materials. Some of the materials was acrylic glass, PVC pipe, PVC cement, a 22 kilo ohm resistor, a single pole, single throw switch, battery strap and battery, and photoresistors. So in order to actually build a probe, we first assembled the housing. And the housing contained the viewing window, which was just a small little piece of acrylic glass that was cut out. And then we PVC glued that to the bottom of the PVC pipe and just let that dry. Then we assembled the electronic components outside the probe, and the electronic components were assembled such that the photoresistors were connected in series with each other, so they would act together as one big photoresistor. And from there, we then attached two very long wires to the top of it, so that we can then attach the switch, the battery strap, and the resistor to it. And this will allow, then from there we attach 2 wires across the resistor, and that would be such that we can connect it to the voltmeter, and that would allow us to then get a positively sloping graph that we can then from there use to compare voltage across that resistor to power level of the reactor. And then we took all the electronic components and fed it down the tube, and that would allow the photoresistors to get near the viewing window. That would allow to best maximize the amount of light those resistors see.
We tested the nuclear reactor probe on the 14th November 2016 at the Burlington Nuclear Labs. We tested the probe by placing it in the reactor pool, and the reactor was then set to 4 unique values: 100 kilowatts, 300 kilowatts, 500 kilowatts, as well as one unknown value. We used the voltmeter to create the following data table, which consisted of the voltage at a different power level. With this table, we were able to derive the following graph, which allowed us to determine the voltage at a different power level.
So at Fed, we ran into some unexpected obstacles, one of which was only one half of our team was able to show up. Just myself and Luke were able to show up, but in the end we were able to rock Fed really well. But the more major obstacle we had to overcome was that our nuclear reactor probe yielded a high error percentage. Basically, in the rubric for our nuclear reactor probe, we were supposed to give out at maximum a 2.5% error, and our nuclear reactor probe actually yielded a 13% error. This is very high, but we're engineers, so we were not very deterred by this, and we decided to problem solve. And we were able to figure out that the graph that we had created actually overestimated the power levels that we were supposed to estimate with our nuclear reactor probe, giving us such a high error percentage, and we were able to fix it in the end.
One of the biggest things we learned from this experience at Fed, from our failure, was how much of a part of it was the presentation. Sam and I really made a point to connect with the judges, make that personal connection, make them smile, allow them to really enjoy the whole presentation. And we made sure to explain why we messed up, if we were to perform this again, what we could do better. And just that overall presentation really increased the quality of the judges' experience.
My advice to the future freshmen that are going to do Fed Day would probably just to get to know your teammates as friends, because when you're friends with your teammates, you'll be able to work more effectively, and you can grow this friendship by just going to different social interactions with each other, or just eating together and really get to know each other.
So my advice in next year's freshmen was just make sure you meet on a regular basis, and that's just to make sure you don't fall behind and deadlines just don't come out of nowhere, because that can just really put a damper on the project and makes things hard.
Early in the project, I would recommend creating a detailed plan of action in which you would meet on a weekly basis, and per week you should decide where you're going to meet, when you're going to meet, and what you're going to tackle in that week. Or not only that, I'll also recommend you creating a group chat and a Google Drive. This will allow members to effectively communicate, as well as all information will be accessible to group members.
And no matter what, make sure to have fun with your project. And if you get the Nuclear Reactor Probe, keep in mind that the constraints of the project make your product very similar to that of others. So make sure to put a little bit of your creativity into it to set yours apart. Thanks for watching. Hope you enjoyed.